Okay, so let's begin our next lesson of this subtopic of Poisson distribution. It's not poison, that's for sure. It's Poisson or Poisson. It's a French word.
Poisson. Poisson.
Okay, understand that?
Du.
Okay, you can check it out yourself how to pronounce Poisson. It's a French word, and I know some of you girls are into French guys because of the slang of the sengau, bahasa Melayu. Okay, alright, let's begin. Okay, what's the difference between Poisson and the other types of probability of distribution? Well, the thing about Poisson, if you're into JRPG, Japanese RPG, and you'll be interested that it has something to do with space and time. I can say things in many ways, but let's say I say this way. There's a highway in Malaysia, North South Highway, and there's steel tool. I hope really that's not political out there. Okay, let's say there's a highway, and then I can say in terms of space that for every 100 kilometer, there will be one accident. Then I'm describing in the term of space. I can also describe in the term of time, such as for every 1 hour, there will be one accident. Where space and time, I can manipulate them, such as I can say, hey, what about for every 200 kilometers? Then will be 2 accidents. I can also manipulate here. What about for every 2 hours? There will be 2 accidents. This is the mean. This is the mu, what we call it. This thing here. It's this thing, the lambda. In this case, we call mu. If there's 2 mu, what do we call it? We call it mu 2. If you're into Pokemon. What about if I say if there's a 50 kilometer? Then it becomes 0.5 or half. Same goes here. If I say what about for 30 minutes instead? Then it will be 0.5 or half. Understand? So we can manipulate the space and time. Mostly it's still kind of the same. There are formulas and there are tables. In this case, the formula is slightly a bit complicated. Px equals to x, whereas e negative lambda to the power of x over x factorial. Do you remember factorial? If I said 3 factorial, what does it mean? If I said 3 factorial, 3 times 2 times 1. Okay? Or for the table method, it's kind of the same as a binomial. Alright, when do you use formula, when you use table? The same thing if I said if this I want to be equal. When do you use table? If less or more. If there's inequalities. Of course, the same rule applies if you cannot find. If no mu or n in table. Your mu is actually your new p. N is still n. Alright, so if you're proficient in finding binomial by using table, then this topic should be quite easy for you. They kind of follow the same thing. One of the main difference between for binomial and space and binomial and Poisson is that Poisson has no maximums. Sorry, it has no n. My mistakes. It has no n. Poisson, it has no max. So other words says there's no n. So it's all about the p's. Okay, so that's a very slight introduction. So now let's us begin. If we write to you something like this, x, they say the x is following the Poisson distribution, PO, and they said to you 3.5. The 3.5 here, it stands for the mu, lambda. So let's try for px equals to 0. Well, you need to memorize the formula. So from the formula, it will be E negative, what's my lambda? 3.5. 3.5 power of 0 over 0 factorial. Press that in your calculator, what do you get? You should get that. Do we get the same stuff? Are you guys okay? Right, next one. Let's just try px more or equals to 4. Oh, I forgot to say one more thing. Poisson is discrete. There's a knowledge precursive bias. I know that. I forgot that you do not know about it. Px more equals to 4. It kind of follows, since it's still a discrete. If it's discrete, what do I recommend? You use the room technique. 0, 1, 2, 3, 4, 5, 6. Until how much? Remember, Poisson has no maximum. So it doesn't have the value of n. It can go and on and on and on and on. So 4 here, so that means, does 4 included? Yes. That means we are going in that direction. Remember that this table, it reads from left to right. Okay, this is from college matriculations. What do you think of this graph? It's quite an old graph, 2010, now it's 2020 already. Because I was the one who designed it. So I'm slightly proud of it. Okay, so let's try. We know that 3.5. 3.5, can you find it? Okay. And I want x more or equals to 4. That means I take 4 over here. Zero 0.4634. Can you find it? Zero 0.4634. Happy? Now, can I use px equal to 0 from table as well? Technically, yes, you can. But me personally, when I see equals, I just prefer formula method. But let's say, hey, I forgot the formula. Let's say you forgot that and you cannot find it in the formula sheet. And let's say you just phobia with it. Then remember that I want equals to 0. So if I do the rule method, I want only 0, right? I want only this one. Oh, my rate is also out. And remember, if I read from the table, it will read all of them. But I only want this. I do not want the rest of it. So what I do is I read from px more or equals to 0. For Px equals to 0, Px more or equals to 0 minus 1 enter the rest. Are you okay with this? I'm asking you one more time. Are you okay with this? If you're not okay, please raise your hand. Thank you. So 3.5, I read 0, 1 minus 1 here. 1 minus 0.9698. Sorry. It will give you the same answer as 0.00302. Are you okay with it? People at the back, can you hear my voice? Thank you very much. Okay, so I want you to try by yourself now. Px less than 4. Px less or equals to 2. I think I'll take this one out. It's not repeating too many same things. Just go to F. Okay? C, D, and F. Do you need my help? Why do you want to try by yourself? Try by yourself. Okay? Alright, good luck. Viewers, all the best. Alright, for those who need helps. For Px less than 4, I highly recommend we use the room technique. Remember, Poisson has no maximum. Less or equals to 4, less than 4, that means less than 4, 4 is not included. So that means that is Px less or equals to 3. Well, we cannot find this directly in table. Why? Because the table reads from left to right. So the table reads in this direction. So how you're going to solve it is by the whole probability is equals to 1 minus Px more or equals to 4. And then you can get your answers. I believe Px equals to 4, we have calculated that. Did I put it? Never mind. It's not that difficult. 3.5, 4, 1 minus 0.4634. I'm going to give you 0.5366. Okay, so for this one, it kind of a similar stuff. We do 0, 1, 2, 3, 4, 5, and so on. For less than 2, we want here, so we do not want this side here. So I rewrite it as Px less or equals to 2 as 1 minus Px more equals to 3. And then you find from your table 3.5, 3, 0.6792, so minus it. 1 minus 0.6792, 0.3208. Okay. What about for F? Can you do it? F will be 0, 1, 2, 3, 4, 5, 6, 7. So remember, the books read from left to right. So we want this moment here. Oh, sorry, is 5 included? 5 is not included. So it will be Px for the P2 x less or equals to 4. Okay, so 5 is not included. I do not want the rest of this side here. The books read from left to right. So it will be Px more or equals to 2 minus Px more or equals to, I stop taking from 5. And just find the value in the table. You can solve them. I believe the answer will be 0.8641 minus 0.2746. 0.5895. Do we get the same, class? Yes. Right, I think good enough to go. Okay, so let's try this example where you tell that the Poisson, the mean is 0.5, and let's say 0.5 for 1 week. Okay, I can be more precise. Mean of an accident okay, so if the question goes something like this, find the probability that there will be no accident in 3 weeks. How are you going to solve this question? Well, take note that the mean is 0.5 per week. Now we are doing for 3 weeks. So you need to find a new mean, new mu. So 3 times 0.5, 3 weeks. I'm adding a little bit from the notes. So your new mu will be 1.5. So right now, you calculate x where there is still a Poisson with a 1.5. So you are changing the value now. Changing the value of mu. And I want for there will be no accident in 3 weeks. How are we going to calculate that? X equals to 0. So the probability for x equals to 0 will be, if it's equal, how do we calculate it? I'm inclined for the formula method, but that's a little bit of troubles. Do you memorize the formula? Not yet. E negative 1.5, 1.5, power of 0 over 0 factorial. Press that in your calculator and tell me what you get. .2231. Okay, so it's not that entirely difficult. Remember, if I change the space-time, I need to change my lambda, my mu. Can I move on? Okay, another attributes about thing. Let's just make another video, I guess. Let's continue. Okay, another attributes for Poisson is that the mean and lambda We know the mean. Mu is the mean. And I can say as well it's the same as the variance. It's a bit different from binomial. Okay, let me just show you a few differences. For binomial, let's say this is your P. And how do I calculate the mean? It's NP. And how do I calculate the variance? NPQ. But for Poisson, they are all the same. You don't have to calculate things. And let's say if they ask you, hey, tell us that this is Poisson. What's the proof that this is Poisson? You calculate all these three and they are giving you the same thing. Okay, normally in exams, the question will say something like this. They say that X follow Poisson distribution. With mean 9. Find the expectation, which is also mean, and find the variance X. How do you answer? Simply equals to 9, simply equals to 9. Why is it equals to 9? Because Poisson, the lambda, and the mean, and the variance are all the same. Understand? Okay, the rest of the chapters are the same with binomial. So I'm not going to explain too much over there. Right, of course there are more examples such as, but it's kind of the same. You just want to find less, more, kind of the same stuff. And less here. So if at least, no cause, stuff like that. So if you're good in your binomials for that, you should be good for this chapter as well. Right, that's all. Thank you very much. We're done for Poisson. Please comment, share, like, and subscribe.